Today, we're talking about endpoint recovery. In previous episodes, we explored how endpoints fail, partially or completely. Now we focus on what happens next. Because in real networks, failure is not the end of the story. Recovery is. We'll structure this discussion clearly around 5 questions. What endpoint recovery is, how it works, why it matters, what features define it, and what its broader implications are for network behavior. Let's begin with what. What is endpoint recovery? Endpoint recovery describes the process by which an endpoint returns to a functional state after a failure, disruption, or degradation. That failure might be partial or total. The endpoint might have crashed, become unreachable, overloaded, misconfigured, or isolated. Recovery does not simply mean that the endpoint is running again. It means the endpoint can once again participate correctly in network communication. A useful metaphor is a hospital patient. Recovery is not the moment the patient wakes up. It is the moment they can breathe on their own, respond normally, and safely return to daily activity. Endpoints behave the same way. An endpoint may restart quickly, but still be unhealthy. True recovery means it is ready to rejoin the network without causing harm. Now let's look at how endpoint recovery works. At the most basic level, recovery begins with detection. The network must recognize that something went wrong. This can happen through failed probes, error rates, missing heartbeats, or degraded performance signals. Once failure is detected, recovery can happen in different ways. In some cases, the endpoint recovers itself. A service restarts. A device reconnects. A temporary overload clears. This is similar to resting and recovering naturally. In other cases, recovery is external. The network removes the endpoint from traffic. A controller restarts it. A replacement endpoint is created. This is like medical intervention. Modern systems often prefer replacement over repair. Instead of fixing a broken endpoint, they create a new one and discard the old. From a network behavior perspective, this is faster, safer, and more predictable. Recovery also involves reintegration. Once an endpoint appears healthy, the network must decide when and how to trust it again. Traffic is usually reintroduced gradually. This avoids overwhelming a recovering endpoint and prevents repeated failure. Think of it as easing someone back into work instead of assigning them a full load immediately. Now let's talk about why endpoint recovery matters. Recovery determines how long failures affect users. A network that fails but recovers quickly feels reliable. A network that fails rarely but recovers slowly feels fragile. In practice, recovery speed often matters more than failure frequency. Endpoint recovery also limits failure propagation. If a failed endpoint is not recovered or replaced quickly, traffic may pile up, retries may increase, and other endpoints may degrade. Good recovery behavior contains damage. It stops a local problem from becoming a system-wide one. From a trust perspective, recovery resets expectations. An endpoint that has recovered cleanly can be trusted again. An endpoint that recovers poorly may cause repeated instability. This is why networks are cautious when reintroducing recovered endpoints. Now let's examine the key features of endpoint recovery. One important feature is automation. In modern networks, recovery is rarely manual. Endpoints restart automatically. Health checks trigger actions. Controllers make decisions without human intervention. Automation ensures recovery happens quickly and consistently. Another feature is state cleanup. A recovering endpoint must discard stale connections, corrupted state, and incomplete transactions. If it resumes with broken state, recovery is only superficial. True recovery requires a clean slate. Graceful recovery is another important feature. Endpoints should signal when they are not ready and when they are. This allows the network to coordinate recovery instead of guessing. A well-behaved endpoint does not pretend to be healthy before it truly is. Isolation during recovery is also critical. Recovering endpoints are often kept out of normal traffic until they are verified. This protects both the endpoint and the rest of the network. Finally, observability is a core feature. Networks must be able to see recovery happening. They must track how long it takes, how often it fails, and whether recovered endpoints behave normally afterward. Recovery without visibility is blind trust. Now let's look at the implications of endpoint recovery for network behavior. First, recovery changes how we design systems. We no longer assume endpoints will run forever. We assume they will fail and recover repeatedly. This leads to designs that favor statelessness, redundancy, and replaceability. Second, recovery reshapes network timing. Traffic flows are no longer static. They shift as endpoints leave and rejoin. Networks must absorb this motion without disruption. Third, recovery affects security. A recovering endpoint may be more vulnerable. Its configuration may reset. Its defenses may be temporarily weaker. Networks often apply stricter controls during recovery to reduce risk. Finally, recovery changes how reliability is measured. The question is no longer whether endpoints fail. The question is how quickly and cleanly they recover. A resilient network is not one where nothing breaks. It is one where broken endpoints are restored or replaced with minimal impact. Endpoint recovery is the closing loop of failure. It is how networks heal themselves. And in modern networking, recovery is not an exception. It is a normal, expected behavior. That is endpoint recovery.